about the fact that there's something really massive that those things are orbiting. And since we can't see it and anything, and we can't really detect it, the only thing that could be that small and be that massive is a black hole. So, and now they've discovered these supermassive black holes in just about every galaxy. And so they're very common. You know, they shouldn't be confused with just your regular black hole.
What's that? Yeah. That was the radio telescope. Or radio, what do you call them? The ones there. You want me to pull you up? Or do you want to go slower?
Go slower.
Uh-huh.
Halfway up the hill here and stop.
They got a seat waiting for you down there. So they got a seat waiting for you up there.
You would think they would have like a jeep for people to get on.
Well, he said you can drive up if you get a pass.
Yeah, but then you'd miss what he's saying. Another road down there.
Uh-huh. Is that the one we drove up, probably? I imagine. I don't know.
Yeah.
All right, we're looking out at a couple of different things here. One thing we're looking out is the Mayall reservation, which happens to be about the second largest in the country, second after the Navajo reservation up in northern Arizona and that. Their reservation actually extends down into Mexico as well. It's how many acres here? About 2.8 million square acres of reservation out there. It's also considered to be what they're referred to as a basin and range area. So the basins is the desert area, and the ranges are the mountains you see out there. So what happened about 10 million years ago is the Earth's crust was rather thin down here, and there's a lot of magma underneath it. And what happened was the Earth's crust would stretch, and there cracks would develop, like there'd be a crack here and a crack here. What would happen then is the area between the cracks would go down, and the areas on either side of it would rise up. So what went down is the basins, and what went up are the ranges that you see out here. And all of these generally run north to south. Now those ranges over the last 6 million years have been weathered down due to rain and the constant sand beating up against them and everything and weathering them down. So there's like about 5,000 feet of material out there in basins now of worn down mountain range into them. So that's what that is. Okay, if you look over here to the left, you're going to see a couple of telescopes there in the foreground here. One to the right is obviously a radio telescope with a big dish there. That's part of the BLBA, or Very Long Base Array. And then there's another radio telescope just to the left of it. That's like a 12-meter radio telescope, and that belongs to the University of Arizona. Now the BLBA is interesting because that is like one of 10 identical radio telescopes stretching all the way from the Hawaiian Islands to the Virgin Islands. So when they're spread out that far apart, that's what you call a long base array. And when you spread them out that far, if they all start looking at the same object, it's like you have a telescope that big in diameter. So you get really good resolution out of it that way. So what do they look at? Well, for one thing, it looks at the center of our Milky Way galaxy, and that's one of the things that they use to determine the fact that there's, you know, like a supermassive black hole in there. It also looks at stars, newly forming stars. Lots of times when they form in these areas where there's a lot of dirt and debris and gas and everything, and you can't see it through the normal part of the spectrum that we can see through, you know. So that's where radio telescopes come in handy, looking through that kind of stuff too. So anyway, like I say, those are radio telescopes, and they operate in what they call the radio spectrum. We have what you call the electromagnetic spectrum. Okay, that's everything from low frequency stuff to really high frequency stuff. Really high frequency stuff is more in the gamma rays and stuff like that, and the low frequency stuff is your radio waves. Our ability to see, we can see somewhere between 400 and 700 nanometers in that portion of the electromagnetic spectrum. So our eyes can only see a tiny little bit of the entire electromagnetic spectrum. You know, there's a lot more there that if you have the right kind of tools to use on it, you can see, such as radio telescopes. Okay, turn around here and we'll be looking up at the bottom of the observatory. So it was construction was beginning in 1967, and it was finally completed in 1973. Now when they prepared this site, they noticed a big crack in the mountain, okay? So what they ended up having to do is drill some holes through the entire mountain, and they ran some big bolts through it. And you can see obviously one of the heads of the bolt right there, about 4 feet off the ground there. Then there's like maybe 3 or 4 more other ones over. So they ran those through and tightened them up, and voila, the mountain stayed together. The other thing they did here was spray this material on here. It's what they call, it's a sprayed on concrete called gunite, at least that's one term for it. So they spray that material on there so that the granite that's behind it doesn't get all worn, you know, and break apart and everything. And I mean, granite makes nice countertops, but it doesn't make mountains that last forever. So they had to do that. Okay.
What's that thing?
It's a GoPro video camera. It's what it does, takes pictures too, but video too.
Okay.
And it can take a picture every 5 seconds too if I want to with the video.
Mm-hmm.
But right now it's just video.
So what would you use that for, like, other than your regular camera?
It's good for like go to a lot, does a lot of sport photography. They do a lot of like underwater stuff. They have cases for these. Do a lot of like stuff with cars and stuff too. I do like video mapping. I put them around the car and then can map an area or carry them around their light. Yeah. They can do cinema quality too. Here they have some like do 4K like they do for movies.
How do you like make your frame? It's not totally in your control, right?
It's fixed. No, I can set it like a wide, narrow, or medium, and you can look at it on like a iPod or something too. It'd be maybe up to 600 meters away. You can control them with the radio, Wi-Fi, and stuff. They don't have a lot of air up here. Do you want to push?
No. It's gonna hurt tomorrow.
Okay, for those who didn't get to the solar telescope, that's an atmosphere solar telescope over there in the distance, that angular structure. Just in front of it and to the right, you can see the big catch basin that we use for catching rainwater and snow melt up here. So what happens is if there's any rainwater or snow melt in that catch basin, it gets pumped out into that one little building to the left of it where it gets filtered and then sent up to the 500,000 gallon tanks just past that little building there.
Wait, where?
There, that way.
Oh, those like gray things?
Yeah, they're whitish tanks. The road you came up on in elevation, it probably starts about the 3 mile mark. When you get up to the top here, that's 12 miles, so it's about 9 miles of elevation you came up on. This here is the original construction road, right here, that they brought up the solar telescope on and the 2.1 meter on. And that road from top to bottom is about 5 miles, so you can tell it's quite a bit steeper. It's not used anymore except from up here down to where that Quonset hut is down there. Otherwise, it's pretty much abandoned.
What?
Abandoned.
But what?
But why? Because it's too steep and narrow and windy, and you got this other nicer road to come up on. That you probably won't get killed on, more likely.
But the public goes drive on it if they want to, and it goes up.
They don't want people driving. Okay, here we are at the bottom of the Mayall telescope. It was constructed between 1967 and 1973. Let's see here. The dome on top, well, the telescope observatory is 187 feet high. The dome that sits on top of it runs around 500 tons. The shutter on the dome 15 tons. The telescope that sits on the pier in there building is what the telescope sits on. And that's a great big pier that's about 37 feet diameter. It's got like 24-inch walls. And the way they poured that, it's about 100 feet high. And the way they poured that is they used what they call a slip form. So that form was like 37 feet diameter, 4 inches thick around it. And what they would do there is they popped it up on top of the mountain there, okay, that form. And then they would pour concrete in it. And they would let it cure for a bit. And then they would raise that slip form up a ways. And they would get more in the camp. Let it cure up and they did that for like 4 days straight, night and day, until they got up to that 100-foot mark. Okay, now that's what the telescope is actually sitting on. The exterior portion of the building isn't in contact at all with that pier because when the wind is blowing and everything, and they can operate, I think, up here to about 45 miles an hour. So when you get above that, they'll shut everything down. But so, you know, if you got like 30, 35 mile an hour winds buffeting the outside of the building, you don't want that being put into the telescope and the mount that it's sitting on. So for that reason, this is actually 2 sections to this intersection. Well, let's see how many we can get in here. Oh yeah, we got some around here. We can do it. Come on. We got room. We got room. Come on.
You sure? 'Cause we